Okay, homework 8, number 7. So in this problem, you're given the following table of numbers, which has 2 rows, and you're being asked to write a loop that divides the first element of the first row by the last element of the second row, and then divide the second element of the first row by the second last element of the second row, until you divide the last element of the first row by the first element of the second row. For part 2, you're being asked to store the values in an array named ratio_rows. And then for part 3, find the largest and smallest values in ratio_rows. So let's try and attempt parts 1 and 2 first, then we'll get to part 3. So first thing I'm gonna do is I just want to copy the numbers. It's not what I wanted to do. So I'm just gonna copy these numbers from the PDF file, and I'll take him to MATLAB. I'm gonna start a new script, and I'll just paste these numbers here, and I'll just call this, it's an array, I'll call it given, or let's call it A, doesn't matter, just call this list of numbers A. And so at the start of the script, I'll just put CLC and clear. It's good practice. And then I have my list of numbers, and now I want to basically, let's write the objective. Divide the first element of the first row by the last element of the second row, right? And then basically repeat this until I have the last element of the first row divided by the first element of the second row. Okay, so technically, and you're asked to store this in an array named ratio_rows. So technically, ratio_rows should include this, should include A of 1, 1, right? First element of the first row divided by A of 2, comma, last, right? So this should be the first element of this array, ratio_rows, and then the second element will basically be A 1, 2 divided by A 2, comma, last minus 1, all the way until I have A of 1, comma, last divided by A of 2, comma, 1, right? So this is the logical description of what I'm trying to find, right? First element of the first row, so first row, first element divided by the last element of the second row divided by A, second row, last element, etc., etc. So it seems that we have all these numbers. The missing number is this last number. And to get this last number, we need to find the length of this matrix, and to do so, we're just going to use the function length, as we talked about in one of the previous videos. So I want to run a for loop. I'm going to use I equals the counter, and I want to run this for loop over the length of this array. So the for loop will be equals to 1 initial value, and the final value will just be equal to length of A, and this will run the loop over the length of the array A. And what do I want to do in this loop? I want to create this ratio_rows array. So before the loop, let me initialize it. So I'm going to say ratio rows equals 0 just to initialize the variable, and then inside the loop I'm going to have ratio underscore rows of I. This will be equal to what? So the first element of ratio rows should be equal to A of 1 comma I, which is the first element or the ith element of the first row divided by this A. So I need the second row and I need the last element of the of the second row, right? So what's the easiest way to implement this number or this element location? And I need to have it go through a loop such that it always decreases. So let's see. So I can say it's equal to length of A, but then in the second iteration I need to include it somehow. So let's create another counter. Let's call it K, and K will be equal to length of A minus I, right? And here I'm gonna say K inside this expression, and before the loop I'm gonna initialize K to be equal to 1, right? And so K is initially 1, and so here it becomes A 1 1 divided by A 2 1, or so I don't want it to be 2 1, I want it to be 2 last. So I should initialize A to be equal to length of A, right? That makes more sense. So this will find the so this is the counter for the second row. So if I look back into my loop, I have I goes from 1 to length of A, so I'm running this loop over the length of the array A. I'm creating this new array, calling it ratio underscore rows, and in this I'm dividing the first element or the ith element of the first row by the kth element of the second row, right? Where I will move basically from left to right and K will move from right to left, and I'm changing K by using this expression K equals length of A minus I. And let me end. So let's try to logically go through this. So initially K will be equal to length of A, which is okay, let's find out this length here. So let's copy this and go to the command window, just type it out, and let's see. So dimensions of arrays being concatenated are not consistent. So we have an issue here we need to fix. So if I write this, so let's try and fix this. I have the first row. Let's write them row by row. Maybe this will help. So I have my first row here. Then this is my second row. Okay, this is not working. Oh, then let's represent it as an array. This way it will count it for us. So I want the same thing, but I'm just gonna add these square brackets so that they're represented as an array. So let's go. So this has 32 elements, and then how about the first line? How many elements are there in the first line? Let's call it B. Then, oh, so the first line has 28 elements and the second line has 32 elements. So let me just remove was it 28 and with 32? So I need to remove 4 numbers from here. So let me do this. And let me just remove it from your homework as well. So let's go back to the PDF and let's fix this problem here. So here I just need to remove these 4 numbers, right? Yeah. So this should be the correct problem. Okay, let's go to MATLAB and continue solving this problem. Okay, so in MATLAB now, let me check this array. Let's see if it makes sense. Okay, here we go. So now it's 28 by 28, or 28 columns, 2 rows. It's dimensionally consistent. And let's measure the length of A, which was the original thought we wanted to do. So length of A is 28. So if I go back and try and logically go through this loop, initially K is equal to length of A, which is 28. And then you enter the loop, and then first iteration of the loop, I equals 1, ratio underscore rows become of 1. So I equals 1, comma, ratio underscore rows of 1 is equal to A of 1, comma 1 divided by A of 2 divided by 28. And then the second line of this loop, K is equal to 28 minus 1, right? So this becomes the second line of the loop. Then you go to the second iteration of the loop. I now becomes 2, ratio underscore rows of 2 becomes A of 1, comma 2 divided by A of 2 divided by K. So here K has to be length of A, which is 28 minus I, which is 1. So K becomes 27. 2 divided by 27, right? Then you go to the third iteration of the loop. Now I is equal to 3, and ratio underscore rows in this case of 3 is equal to A of 1, comma 3 divided by A of 2 divided by 26, because here K is equal to length of A, which is 28 minus I, which is 2, right? And again, now K becomes updated to become length of A, which is 28 minus I, which is 3. And you keep on going, and this should achieve your objective. So if we do it this way, we should get what we want. And just a comment about why did we include K after ratio rows and not before? So why was this K counter or K increment, or why was this K counter included after this line and not before this line? So if you want to include K before this line, you have to be careful about what you're trying to do, because if I include K before this line, and an I will always start from 1, so I'll still need to add a second line after this ratio line to change K and correct it. So in doing this type of logical approach, it always makes sense to put your second counter after your expression. Alternatively, you could also use nested loops. So I can run a nested loop where I have K here and I run it twice every time. So there are many different ways to do it. Just structure your problem and try to solve it to achieve the objective. Okay, let's run this and see if it's going to achieve the objective. So before doing that, after this loop, I'm going to write display ratio underscore rows. Okay, let's run it to ask you to save it in a location. Just find the location. I'm going to call it homework 8, number 7. So let's do this. And here we go. So you're able to get your 28 rows, which include the ratio of the first number divided by the second number. Or sorry, the first element of the first row divided by the last element of the second row. etc. And we can check it. So we can check the first element, or we can check the first element of the first row divided by the last element of the second row, which is 1 divided by 4787. You're going to get this. And if I call ratio underscore rows of 1, it's the same number. And then the last element of the first row, which is 31781, divided by the first element of the second row, which is 2. I'm going to get this. And if I check my array ratio rows of 28, we said should have the same number. Okay, so we're getting correct values. So let's go back to the problem statement and see what's part 3. Part 3, find the largest and smallest values in ratio underscore rows. Okay, so let's go to MATLAB and see how we're gonna achieve this. So I'm going back to my script as well, and now I need to find the largest and smallest values in ratio rows. And this is similar to a problem in homework number 6, where you're going through a loop and trying to find the largest and smallest values, right? So I can do it using a second loop. So let's go for I equals 1 to length of ratio underscore rows. So this is part 3 of problem 7. So I have, let me just move this up. So I have for I equals 1 to the length of ratio rows. So I'm basically, let's add a comment here, running a loop over the length of the array ratio underscore rows. And what do I want? I want to find the maximum and the minimum. So let's create some shell variables where we're going to store these maximum and minimum values. So let's say maximum, let's call this maximum ratio. And I'm going to initialize it to 0. And then minimum ratio, I'm going to initialize it to infinity. And the logic of initializing, when you're looking for a maximum, logically you initialize it to a small number. And when you're looking for a minimum, logically you initialize it to a large number, right? When looking for maximum, and this, you can think about it and try to convince yourselves, but this is the good practice when doing this type of operation. Because if you extrapolate to certain extremes, if I initialize my minimum number to 0 and I have a negative number, for example, it's not going to work. Similarly, if I initialize my maximum number to like 10 and I have a number which is, when my maximum number is less than 10, it's not going to work. Okay, so what do I need to do? So I need to check every element in this array. So ratio rows of I need to check it. So if ratio rows of I is greater than my current maximum, then my current maximum is equal to ratio underscore row of I, right? And this is end. So this is the if end statement. If end statement to determine the maximum. And then I need to do logically the opposite. So if end statement to determine the minimum. And here I'm gonna have if ratio underscore row of I is less than minimum ratio, then minimum ratio is equal to ratio row of I, right? And we talked about this in homework 6. So go back to that homework and try to go over that problem again to try and see the logic. But logically, what I'm doing is I'm running the loop over all the elements in this array ratio rows, and then I'm checking every element. I'm comparing every element versus itself, basically. So if the first element of ratio rows is greater than 0, then I want to store this element here. Then I'm moving on to the second element of ratio rows, comparing it to the first element. The bigger one will be stored in the variable maximum ratio. Going to the third element, the bigger one will be stored in the variable max ratio, etc. Similarly, for the minimum number, I'm comparing the first element to infinity. So if it's less than infinity, then I'm storing the first element in this variable minimum ratio. Now I'm comparing the second element to the first element, storing the smaller number in the minimum ratio, comparing it to the third element, storing it in minimum ratio, etc. until I'm done with my array. Okay, so if you run this, you should be able to get your desired numbers. Again, I'm going to suppress these, and at the end I'm going to display minimum ratio and maximum, and then display maximum ratio as well. Ratio, here we go. I'm going to suppress this array as well. I don't want it to show in the results. And let's run this loop and see the results. So I have an error here. Let's try and to troubleshoot it. Undefined function or variable ratio underscore row. Okay, so I have a spelling error here. So I need to call it ratio rows. Ratio rows, I just need to add an S. Here as well I need to add an S. And here I need to add an S. So that I'm consistent with the naming. So I'm using ratio rows, ratio rows, ratio rows, rows, WS, WS. Okay, sounds good. Let's run it again. And here you go. It's you're able to get your minimum number and your maximum number from the ratio rows array. Okay, so this is how you achieve, this is how you solve homework 8, problem 7. Go through it, try and replicate this, think about it. If you have any questions, please come to office hours and I'll explain it to you in more details.